Okay, so again, because this is a square, you have your 45, 45, 90s. And because it's a square, this is 90, this is 90, this is 90, this is 90. And the diagonal splits those. So I have 45 and 45. And that means I know this side length and this side length, that's going to be the same. So ratios. So let's change this X again. Like I said, like it could be a heart, it could be a smiley face, it could be a puppy dog, it could be whatever you want it to be. But the ratios around this for 45, 45, 90 is X, X, and X square root of 2. So that's the relationship between each side to each other. Since this one, which is great, we get the 11, that means if my ratio X is going to equal 11. So then up here, if the side we're trying to solve for, so like heart side, is X square roots of 2, then your answer is going to be just plug in that ratio 11, and that's going to be the length of heart side. Or in this case, on the delta math, it's X. So it's 11 square roots of 2. So if they give you the legs instead of the hypotenuse on a 45, 45, 90, you just take that number and put it in front of square roots of 2. But again, you have to memorize that the hypotenuse of a 45, 45, 90 is square root of 2. Now, as a backup plan, because these two sides are the same, you could actually do Pythagorean theorem, but it will really only work, from what I can tell and what I've been able to see easily, for 45, 45, 90s. Because that means both sides. So that would be that 11 squared plus 11 squared equals c squared. That's 121 plus 121 equals c squared. That's 242 equals c squared. And we got to get rid of the squared. So we're going to take the root. And then you would have to simplify that radical of the square root of 242. I got too much stuff on the screen, sorry. So then that would be 121 times 2, right? So that would be the square root of 121 times the square root of 2 equals c. Square root of 121 is 11. So that's how you get that 11 square roots of 2 in the most simplified radical form. So as a backup plan for your quiz, if you have to forget one, like you don't have extra space in your brain, or you want to really focus on something else as well with your time, the 30, 60, 90, there's not a way to get around it, really. Unless they give you, no, there's really no way, unless you have two sides given for you to use Pythagorean theorem. But 45, 45, 90, if they give you one of the legs, then you can use Pythagorean theorem. So the answer that I'm working on right now is 11 square roots of 2. Excellent. So this one, we don't have the leg given. We have the hypotenuse, which is going to make it a little more complicated. I'll show you how to do Pythagorean theorem, but again, the benefit of just memorizing is probably going to be better. So again, our ratios for this one is going to be, x, x, x square roots of 2. So ideally, we know that x square root of 2 is given as 4. So we're going to divide by the square root of 2. We can't leave that square root of 2 on the bottom. So this now just becomes x equals 4 over the square root of 2. So we're going to multiply by the square root of 2 and the square root of 2, which will give me 4 square roots of 2. Again, the square root of 2 times the square root of 2 is just like squaring it, or we could call it the square root of 4. So once it's simplified, it's going to be a positive 2. Then you want to simplify these whole numbers. The 2's can't cross out because the one on the top is that radical. So 4 divided by 2 will give me 2 square roots of 2. So that should be the answer to that problem using your special right triangle ratios. Just because we discussed the Pythagorean theorem, this would be x squared plus x squared, because they're both x values because they match, is equal to 4 squared. So then you would have 2x squared equals 16. You can divide by 2, 2.
x squared equals 8. Take the square root, and then you have to simplify that again, which would be square root of 2 times the square root of 4. Square root of 4 is 2, so it's 2 square roots of 2. So that would be, this is the Pythagorean theorem way of solving that problem. Again, it's sort of whatever sticks for you. Okay, good, another 30, 60, 90, because I feel like they're a little messier. Right. So I go straight into making sure I know. Yeah, Pythagorean theorem is just a lot longer, more mathy. But you can ask any 30-plus-year-old adult in the world, what do you remember from math? And a squared plus b squared equals c squared is something that everyone rattles off. So it's a backup plan if necessary. Like if you just like come up blank on a 45, 45, 90, it's better than having no backup plan. So across from 30 is your x ratio. Across from 60 is your x square roots of 3. And your hypotenuse is always 2x for our ratios. So from here, we know that x is equal to square root of 2 because that's what they gave us here. And then we need to solve, in our x ratio, I should say. So we need to solve for the hypotenuse. And the hypotenuse has 2x relative to our ratios. So we're going to plug in 2 times the square root of 2. And that's it. Because you can't simplify it anymore. The square root of 2 is the square root of 2. When it's across from 30, that's beautiful too, because then you don't have to do quite as much math. And like I said, that one's not really an option for your Pythagorean theorem. Let's get this one. Oh, you're good. You're good. You're beating me to it. All right. So again, equilateral triangle, which means all three angles are 60 degrees. So this is our 60, this is our 60, this is our 30, and then 30 if we were looking at the other triangle. But our focus is on this triangle on the right. Across from 30 is x. Your hypotenuse is always 2x. And then across from 60, and I probably should have switched colors, sorry. Across from 60, the ratio is this x times the square root of 3. Again, it's my favorite when they give you the side that's across from 30 because that's it. That's x. And then you just plug it in. So at this rate, 30 is 10 on that side. So that 10 just goes in the place of x over here solving for the x they're asking for. So since x is equal to 10, if we know the ratio is x square roots of 3 over there on the side we need to solve for, then we're just going to plug in 10 square roots of 3. And the square root of 3 can't be simplified, so you're done. That's it. 10 square roots of 3 is for that side. Yay. And I hold my breath every time. All right, so this one notation is just a little different. But it's still, because you should know that because those two sides, which is what I mentioned in yesterday's video, because those two sides are congruent, you should know it's a 45, 45, 90. Because if the two base angles are congruent, and by base angles, I mean these two. If you know the angles are 45, then you know these two sides are congruent. If you know these two sides are congruent, then you know these two angles have to be congruent. And since you have 180 for a triangle, you use 90. Leftover is 90 divided by 2 is where the 45s come from. So this ratio is x, and then x square roots of 2. And I hope when I say ratio that makes sense. The relation to each side, the rule for 30, 60, 90, 45, 45, 90 is kind of what I'm talking about. So they want us to solve for their leg instead of hypotenuse. So in this case, the ratio of x square root of 2 is equal to 7. And we need to solve for x. So then we're going to divide again by the square root of 2. Square root of 2. And that's x equals 7 over the square root of 2.
We can't leave the square root of 2 on the bottom. So we're going to multiply by the radical on top and bottom, because the same thing as 1. 7 square roots of 2. And the root twice gets rid of it, so it's 2. And unfortunately or fortunately, at this rate, 7 cannot be reduced by 2. The 2 can't touch the 2 under the radical because they're not like terms. One's a radical, one's a whole number. And so at this point, x equals this, their x. So the leg equals 7 square roots of 2 divided by 2. So just kind of ugly. And luckily, there's not been a whole lot of the reducing of the radicals. I'll make sure to put at least a video or 2 of those on there tomorrow in case the reducing of radicals is what's making you nervous. I might find one also on getting the radical out of the denominator in case you need to practice that too, because that seems to be a bit of some of the mental block. All right, so we've got that one. So yeah, we got another 30, 60, 90 because it's an equilateral triangle in the details. And again, that means this side is equal to the whole side is equal to that side. So then we have 60 and 30. Across from your 30, ratio is, this is x. Across from your 60 is x square roots of 3. And then your hypotenuse is 2x. So hopefully this one, because again, like I said, when they give you the 30, like across from the 30, the leg opposite 30, you just take it and plug it in for whichever side they need. In this case, they want the hypotenuse. So since x is equal to the square root of 2, we're going to plug it in. 2 times the square root of 2, because that's 2x. And that's going to be that hypotenuse. So not much math on that one. Again, that's just a matter of memorizing the ratios of the sides and how they all relate to each other. Excellent. So this is another one where it gives us the opposite of 30, which is good because that's the one that makes it the easiest to just not have to do much math. So again, we just cut that 60 that was in the top in half with our perpendicular bisector, and then there's our 60. Then our ratio, so across from 30 is x, across from 60 is x square root of 3, and across from 90 is 2x. So in this case, x equals 9 for our ratios. Not to the answer to the problem, but just to set up our ratios. And then to solve for the hypotenuse, that's 2 times x. So that means we're going to do 2 times 9. So the hypotenuse is going to be 18. Or the x for this problem is 18. And then do one more 45, 45, 90. Oh, you're good. You got me. So since this is a 45, 45, 90, then you know the two, like in this case where the x's are going to be the same. And then your hypotenuse, which is always going to be x square roots of 2. So this is x and x for our ratios. And you know it's 45, 45, 90 because of the 2 congruency marks on your legs. And then so x square roots of 2 is equal to 3. So we need to solve for x. So that means get rid of that radical 2. So we're going to divide both sides by the square root of 2, which you can roll your eyes now because that means we have a lot more math to do. Because you can't leave the radical on the bottom. Square root of 2 times the square root of 2. And again, that's the same thing as 1. So we're not really changing it. We're just making it look different. So work straight across the top, 3 square roots of 2. Work straight across the bottom. So again, as we talked about, that square root of 2 times the square root of 2 would give me the square root of 4, which reduces to 2. Or think about the square root of 2 squared, which gets rid of your root, which also gives you 2. So then we have a 2 on the bottom. Unfortunately, the 2 in the radical can't be reduced with the whole number 2 on the bottom. So our answer is stuck because 3 and 2 don't get any better. How you feeling? You want to do some more? You getting the pattern, or you want to do a couple more? Okay. So do you see what I mean? Like, it's just a matter of, like, you just have to do enough to where it's